Yes, sir.
Thank you, Rakibul Alam. Sadia Hussein. Nusrat Jahan Lubna.
Yes, sir.
Thank you. Tawheed Ahmed. Thank you. Umaira Jannat.
Yes, sir.
Thank you. Imdadul Islam Imam.
Yes, sir.
Thank you. Shahuran Hussein.
Present, sir.
Thank you. Shafiuddin Shaji.
Yes, sir.
Thank you. Jumail Ahmed Khan.
Present, please, sir.
Thank you. Nahid Hussain.
Yes, sir.
Thank you. Bushra Kabir Jannat.
Yes, sir.
Thank you. Khurshid Hussain Siam. Aklima Norin Toha.
Present, sir.
Thank you. Azmir Priya Nithi. Shariar Haq.
Yes, sir.
Thank you. Anybody left for giving the attendance?
Sir, Jamila Samlikhani, CL20.
Okay, thank you.
Sir Mahmudul Hasan. Sir,
Thank you.
CL 21.
Anybody else? No. Okay. Yeah, so today is the review class. Yeah, so we have completed total 9 lectures. So the things that we have studied, there is um, the all 9 chapters that we need to be studied for our final examination. So we can see that from the beginning to end, what are the topics that actually we have discussed. Mm, yeah, and that the consultation hour is going to be held tomorrow, as you know that at 8 p.m. Okay, so in the first lecture in the communication, data communication and computer networks overview. So we start the discussion with the computer communication, and there are various applications are there. They are based on that the communication system. We have talked about connectivity, wireless regulation, and this is the part that we say there are 4 basic elements. These 4 basic elements are going to be available in every communication of systems. These are the sending and receiving devices, communication channel, connection device, and data transmission specification. With this example, we have tried to identify all these basic elements, and then later on, actually, we try to explain these basic elements one after another. If it is a computer communication, then there is going to be the 5 type of basic elements. You have to include the masses. So in case of sending and receiving device, we did not create a separate file. The reason behind it that, I mean, it's a very simple thing that sending device is going to be the, if you're a sender, you're sending something to that someone, so you are going to be the sender, and the device you use, uh, that is going to be the sending device. And in the receiver side, the receiver will receive the data or message through his device, that is going to be the receiver device. Here example that mobile phone, computer system, and so on. Then we are having the communication channel. So for that we are having a separate discussions. So we say that this is the medium where the data will be carried. We are having the 2 types of communication channel: the physical connections and wireless connections. The physical connections, we are using this 3 different types of cables. So we have introduced them, and we say that who is actually fastest among these 3. Then we have moved for the wireless connections, and here we are using actually the different types of the wireless communication techniques. the wireless technologies like that radio frequency, microwave, satellite, infrared, 3G, 4G, 5G. These are the type of the wireless connections. So now after that we have moved for the connection device. So here the connection device we have explained with the model. So we have tried to say that there is going to be modulator and demodulator. So if you're a sender, your data is going to be converted digital to analog, and if you're the receiver side, the receiver is going to be converted to the analog to digital. So with that the modem we have tried to explaining that the connecting device, we say there are different types of modems are there, and as well as that, as a connection or connecting device, you can think like that router is a connecting device, for example. So here different types of connections has been said in earlier days, that the different types of connections actually we are using, and their types, their connection types, and their speeds that we have discussed here. And then that the last one was the data transmission specifications. Here actually we have focused on that the different factors that affects the data transmission. So the bandwidth, data flow, data direction, and protocol. So we have separately discussed them. The bandwidth, there are 4 types of bandwidth we have discussed. The data flow, the serial data and parallel data, the data direction, that's simplex, half duplex, and full duplex. This we have studied. In case of the protocols, we define that what is a protocol, and we have tried to compare that what is the difference between the human protocol and the computer network protocol. Then we have introduced the TCP/IP protocol standard, and we have discussed a bit about the TCP/IP. There are different example protocols that we have shown, and this is that the different factors summarizations have been shown into this table. Then we start the network discussions with that the different terms, we introduce some terms. Then we have talk about the basic types of computer network like LAN, MAN, and WAN. So we have studied them with that the examples. We have studied that why we need the LAN, MAN, and WAN. What are the use of them, and how they can be developed, and how they works, and then also we have compared them LAN, MAN, and WAN. So these are the some of the networks that are based on that the LAN that we have discussed, metropolitan area and wide area, with example figures we have explained them. Then we move to the network architecture. In case of network architecture, we have said that network architecture means the network topology and the strategies. So there are 6 network topologies. We define that what is the network topology, we define that what is the network strategies, and then we have discussed that 6 different types of network topology and few of network strategies with the examples. Then we have talked about the organizational network that includes the intranet and extranet. So we discussed with the example that what is an internet, what is an extranet, and we also compared them. And also we have make another comparison, internet and extranet with the internet. And the firewall, this is actually the computer security. We have said that what is the firewall and what is the proxy server. Okay, with that the illustration. So that was the lecture number 1, the things we have studied. In the lecture number 2, we have mainly discussed about the network modeling. So when we started the network modeling discussions with the layering task. We said that actually if a system is divided with that layer with the layers, then that it is easy to understand that actually how the step by step works are going to be done into that system. So we have gone through with an example for understanding that layering concept. Then we have discussed the OSI model. It's a standard model for understanding the computer networks. The network layers are divided into 7. So we have studied all of them with their responsibility and services. So we should need to know that what are the responsibility of each layers and what are the services they provide. At least 2 services of each of the layers you should know. So that is these first top 3 layers are known as support layers. You're having the transport layer there on, and then the layer 1, 2, 3 is actually our network support layers. So with this example, we have said that there is a sender and there is a receiver, and we have used two routers. These are known as intermediary nodes. And with this example, we have shown that how the encapsulation process is going to be done in case of OSI. And after encapsulating it, when you're going to be sending it, how the receiver intermediate node is going to be receive it and check that this the packet is for him or not. If it is not for him, then how it is going to be sent to the next node that has been shown. Then again it check that, I mean, it is the packet, this packet is for him or not. If it is not, then how it is sent to the next node, and it confirmed that yes, this data is for him. And then the upper layers, this is the process actually called the decapsulation. So this is how that the message is going to be seen by the receiver device. So this is another example that we shown that with the data in every layer, we are actually using the header. In case of data link layer, we are using the trailer as well. That is actually for error correction, error control. So encapsulation process, and this is that the headers and trailers are removed uh, to get the original message into the receiver side. So these are the responsibility and that the services, different services for each of the layers we have discussed: application layer, presentation layer, the responsibility and the services, session layer responsibility services, transport layer responsibility services, network layer responsibilities and services, data link layer responsibility services, and physical layer responsibility and services. So you should need to be the responsibility of each layer you should need to be know, and as well as minimum two services from each of the layers that you should need to be know. The summary of that the 7 layers. And then we move to the TCP/IP protocol stack. There we have seen that there are actually 4 layers, but for making it better understanding and compare it with that the OSI model, we have keep them 5. So you can see that these 3 layers are combined in a single layer in the TCP/IP model, TCP/IP protocol stack. This is the layer number 5, and that the rest of the layers are same. Even though actually we call that the third layer is my internet. In OSI model we call it network, so we can call it network as well. As I said, this is that the different protocols are present into the different layers. So you have to know their full form, the protocol's full form, and which layers they belongs to. And then it is shown for the encapsulation and decapsulation process of TCP/IP protocol stack. So it is similar to that the OSI encapsulation and decapsulation process. Only here there is the 5 layers. There was the 7 layers. So that the description of this encapsulation decapsulation process has been given into this slide number 22. Then we have talked about the network addressing, and we know there are 4 types of address. And here we shown that the relationship between the TCP/IP layers, 5 layers, and that the addresses, which layer actually, which address, which layer it belongs to. That is actually have discussed here. Then the physical address, we said this is the 48 bits, 6-byte size of that the physical address, which is actually the MAC address of the system. So it's going to be look like this hexadecimal. And then we have with that the example we have tried to learn that what is the how the physical address works. Then we have gone for that the logical address. Yes, this is the 32-bit address, and we have I mean, several times we have discussed it that actually how the logical address is going to be work. Actually, from a network, a source from a network, the receiver in another network. So how the packet is going to be traveled, so that the different routers to the destination. We have seen with that example, it has been said here that the physical address will change, but from hop to hop, but the logical address is going to be remain same. If the logical address changes, that means receiver will never able to receive that the message the sender has sent. Port addresses, we have seen that 16-bit port addresses we are having. Yeah, port addresses is used in the transport layer, and yes, this is actually process for the process to process communication. So we are using the port address so that the sender and receiver can assign a port and for accessing a process between them. So here it said the physical address will change, but the logical and port address will remain same. And the specific address like email addresses we are having. So this is a unique address. This address could not be uh, gettable by anyone else than me. And the domain name you're having that www.google.com, so that is also a specific address. This is also unique. Unique. I mean, so you cannot get not no organization can get a domain with the same name. So this is a specific address as well. So this is the lecture 2 we have studied. The lecture number 3, we started the discussions with application layer, and part 1 we have actually discussed about the DNS, the domain name system. So we have actually explained that why we need the domain name system. Uh, so we have already said that, I mean, the numeric address and name address. So it's difficult that the human will remember that the numeric address. That's why we need a system like DNS actually who is going to help us. If we are writing the name address into the URL into the browser, then actually that DNS is actually going to be provide the IP address for that name. Yeah, as because I mean, without the IP address, no node will be able to communicate with the other nodes. So that's why DNS is actually going to be there to convert that the type the URL I'm typing and entering, that it is going to be give us that the IP address for that. So explain that the purpose of the DNS here. Then we have talked about the two namespace, flat namespace and hierarchical namespace. With the example, we have seen that how they works. And then we talked about the domain namespace. There are different things we have defined, like domain namespace, level, domain name, FQDN, PQDN, and the domain, then the hierarchy of namespace, root server, primary and secondary server, zone. So this we have actually defined, we have discussed. And the domain namespace in the internet, we say that there are generic domain and the country domain. Also, the inverse domains was there, but it is not anymore. We are not using inverse domain anymore. So this is actually reflect on the generic domain and country domain. So we've discussed that what is the generic domain, and we have seen that 14 number of levels we are having. So we have shown an example that how the generic domains has been represented. The country domain, similarly, that the country domain, there are two character abbreviation for each countries. And the example we have shown that how the country domains actually has been represented in the internet. Inverse domains, we have skipped that because it is not using anymore. The resolution that we have said that what is that the name address resolution is, what is the resolver. We are talking about mapping address, name to address, and address to name. And we have studied these two techniques, the recursive and iterative, with that the examples. And also we have said that with the caching method, that the recursive isolation technique can be improved. So this was the lecture number 3. And the lecture number 4, we have studied the HTTP protocol. So the HTTP protocol follows that the client server model. And yes, I mean, the HTTP protocol is now supporting the persistent connection. Earlier days, we are using the non-persistent. So we have, with example, we have understand that what is the non-persistent, what is the persistent connections are. And we have, this is the example here. So we have learned it out that actually persistent connection is much better than the non-persistent connection. Then we are having that the HTTP transactions. We have talked about request message, response message. So we have seen that the components that are available inside that the request message and response message, including that this figure also. That, what are the components we are having? What are the components we are having in the request message and response message? Then we have explained each of the component like request line, status line. So we have said that what is the format of the request line, what is the format of the status line, and we have discussed about request type, that is our methods, and then URL, the uniform resource locator, and HTTP version. So this is actually shown here, and then here HTTP version is started with the status line, and status code and status phrase that we have explained here. Then we have talked about the header. This is the second component of that both request and response message. So what is that header does, and what is the format of the header? And there are 4 types of headers are there. So what are they, and what purposes they have actually used, which actually used into the sender request message and which is actually used to be the response message that actually we have discussed here. Okay, so then with these examples, actually we have tried to understand that each of that the line of that the request message and response message. So we have made a discussions in detail for these examples. The proxy server, yes, HTTP supports the proxy server. Yes, if there is a proxy server, then in several cases that it is going to be reduce the delay for finding the informations. The client is searching something, so it is going to be first search to that the proxy server. If it is there, then immediately it is going to be reply. But if it is not there, then it is going to be sent to that the internet and go to that the particular web server. And it's going to be bring that the information to the server. From the server, it is going to be provided for the future use. Another client is requesting for same data, so that is going to be delivered immediately. So you can save the time as well as you can reduce the load of that the internet if you're using proxy server. The FTP server, then we have discussed, it is a bit different protocol, that file transfer protocol, because it is using the TCP services and it's using the two types of connection. One is the control connection and one is the data connection. The port number 21 for control connection, port number 20 for data connection have been used. And the control connection, without the control connection, it's actually establish the connection as well as after is the data transfer, actually it is going to be used for that the connection termination. Yeah, and the data connection is for data transferring. So we have seen that there are two modes of the FTP, active and passive mode. So we have studied them with the example, the active mode, how it works. The example we have studied that how the passive mode works. And then also we have said that in which scenario or which purposes that which mode is going to be better. The simple mail transfer protocol SMTP, here we have said that, I mean, how an email transaction is going to be happen between the sender and receiver. So when the sender is going to be sending email, that the email is going to be first sent to that the sender side email server, and through the internet it is going to be received to that the receiver side email server. So for this that we call the push the email from that the sender side to the receiver side email server. So in that case we are using the SMTP protocol. And pull protocol, that when the receiver is going to be logging, you'll be able to see that an email has come. So he is going to be able to pull the informations from the server to that his computer. So in that case, we are using any one of the protocol. Actually, you'll be able to use the POP3 or that IMAP. Then we have moved further the web architecture. So we have discussed about that. What is the www? And yes, that the informations are in the internet shared or distributed among the different locations, like the different sites. For example, we have seen the architecture of www. Then we have defined the browser and architecture of the browser we have discussed with that example. The server. So we have discussed that what is the server, caching memory and multi-threading, multi-processing. These are the processes actually improve that the data access from that the servers. Uniform resource locator URL. So what is that the URL is? What is the format of the URL? That we have discussed. And in case of that the web architecture, yeah, so we are also talked about the cookies, and an example we have actually discussed it, how the cookies works. And then we have discussed about web documents, static, dynamic, active. So each of them actually we have learned that in which purposes the static document has been used. Example and figure with the example figure we have tried to understand. And we have also seen that what are the languages actually have been used for the static. In case of dynamic, same thing we have done with that example we have explained that how the dynamic documents are going to be worked and what are the languages that are used for the dynamic documents, that has been discussed, as well as for the active documents, and that we have discussed with an example that how the active documents is going to be worked, and what are the languages is going to be used. So this is that for your reading purposes, stateless and comparison between the stateless and stateful protocol. I have read it here. This was the lecture 4. In the lecture number 5, we have talked about the transport layer. So first of all, we have talked about that what are the different responsibilities the transport layer has, and then each of them actually you have tried to explain. In the process to process delivery, we have shown that actually the comparison of process to process delivery with that node to node delivery and the host to host delivery. So we have seen that actually the process to process delivery between that the nodes that use the addressing. So yes, we have discussed here that icon and ranges. So we know that these ranges are divided. We are having the 2 to the power 16 ports. So we are having some of that three types, that well-known ports, registered ports, and dynamic ports. So that the address actually we are using here. So in the case of sender side, he is using the dynamic ports, and the receiver server side, that is the well-known ports, and how it works we have discussed. Here it has shown that what is the comparison between that the port address and IP address. And then the socket address is a combination of IP address and the port address. We have discussed briefly that what is the multiplexing and demultiplexing with the two example figures. Then we have discussed in detail that the connectionless and connection oriented services. And we have detailed studied a protocol UDP for the connectionless, and we have studied the STCP for the connection oriented protocol. We also compared that what are the reliable and unreliable services. So that will come also the discussions of UDP and TCP. If it is a connection oriented service, then it's going to be reliable. If it is a connection less, then it's going to be unreliable service. We have discussed that the transport layer basically supports that the arrow control and flow control, like that the data link layer does. The flow control, we have discussed that what is the flow control and how it works with the different examples. Then we have studied the TCP and UDP protocol. We started the discussions with the UDP. So we said that what purposes UDP is going to be used. We have talked about the user datagram of UDP. So that is actually the header plus data. And the header has that the 4 fields. This is the 8 bytes information, 4 fields. That the 4 fields actually we have discussed in detail. The source port, destination port, total length, and checksum. And we have taken an user datagram, UDP user datagram, and we have find it out that what is going to be the source port, destination port, then that the length of that the whole UDP packet, and the total length of the data. So we have learned it that how we can calculate this. Then connection-less service, UDP is a connection-less service, and the flow control does not support by the UDP. Control does not support by the UDP, but there we are having a checksum. So that the checksum, only the receiver will be able to detect that in the received data there is an error or not. If it is find error, then simply the receipt packet is going to be dropped. If no error found, then it is going to be sent to the upper layers into the receiver side. So then we have discussed the checksum in detail that the examples. So we all know that how to actually calculate it. And conjugation control does not support by the UDP, and encapsulation decapsulation is that is this is as it is for that the TCP/IP protocol stack. Encapsulation and decapsulation we have used. Only difference is that in the transport layer we are using the UDP header, UDP data in both sides, the sender and receiver. Yeah, the UDP uses the queuing method. So for the client side and receiver side, both are going to have that incoming and outgoing queues, and how they're going to be used that we have discussed. Yeah, UDP supports multiplexing and demultiplexing. And the last, we have said that some application that where the UDP protocol has been used. Then in the lecture number 6, we have started the discussion of the TCP, and we have started the discussions the TCP by comparing it with the UDP, and then we have said that this is the TCP service, process to process communication, the stream delivery of delivery services, the TCP follow stream delivery. And we have seen that it is using the buffers in the sender and receiving side. So we have learned it that in the sender side, we are having the 3 chambers, and we said that how these 3 chambers are going to be worked. And the receiver side, the 2 chambers, how it is going to be worked. So the example we have discussed this. The segments, yeah. So we say that it is 1 byte each time it is going to be sent, but here we are saying that no, it is going to be sent as a segment. So in the segment, that can be the 1 to n number of bytes. So the segment 1 and to that the segment n can be sent. The process, two chambers, that is going to be same explanation. The full duplex communication, yes, TCP is a full duplex communication. Both way data transfer can be done at the same time. The multiplexing and demultiplexing, yes, TCP supports connection. It is a connection-oriented service, and it is also the reliable. So here actually it has been given an comparison between the connection-based service and connection-oriented service. One of the example actually it has been shown. And these are byte number, sequence number, acknowledgement number. These are the three key keywords you need to be understand for knowing that how a TCP connection works. So we have understanding these three keywords we have explained with the examples. And then it supports TCP supports flow control, error control, congestion control, all of them. And this is the TCP format, the segment that you should need to be know. All that the inside the header, what are the fields are there, you should need to know. You should be able to draw this figure. And we have actually explained each of the fields what they does. And then there are 6 flags, as been given that the description of the 6 flags. And then the TCP connection, there are 3 phases. So these 3 phases, how it works, that we have actually studied. And it has been separately shown that all of these 3 phases, but in our class, the whiteboard, we have shown that actually how the connection establishment done, data transfer is going to be done, and that the connection termination is going to be done in a single example. We have combined all 3. So this was the TCP versus UDP comparisons. So we have compared it, and this is how this lecture finished. We move to the network layer, lecture number 7. In the network layer, we have firstly discussed that actually we know the responsibility of network layer is to find the routes between the source and destination. So we have seen an example and we have shown that actually how this routing process is going to be done for making connections between the A and B. So for the discussions, we have been that the switching that it required the router when it is going to be received a packet, it should need to be switched the packet to the appropriate routers. So how it is going to be done? That the switching method. So there are 2 types of switching: circuit switching, packet switching. In the computer networks, actually we are using packet switching. Circuit switching example can be that LAN phone. The packet switching network. So this is the summary, the previous slides, that discussions. And then it's showing an example figure to understand that what is the difference between the connection-less and connection-oriented packets in the switch network, packet switch network. What is the difference between the connection-less and connection-oriented? IPv4 header format. So this is also very important. Header format. This is the IPv4. Okay. So Internet Protocol version format. So you have to know that how to draw this and what are the fields are there and with how many bits. So we have actually given that description of each of the fields. We have make a detailed discussion of it. Then we have moved for that the fragmentation. So we know that for the fragmentation, we are actually using these 3 fields. So that the explanation has been given, and then we have seen also a numerical example for the fragmentation. So we all understood this. Then there are some exercises been given to you to practice at your home. And the rest of the field of the IPv4 format has been discussed here. Then we have talked about the delivery, forwarding, routing. We have defined them. And then we have discussed about the delivery. So we have seen that delivery, indirect delivery, with example, we have explained them. And then the forwarding, there are different techniques for forwarding that we have studied. And after that, we have seen that forwarding process for the class-based addressing. So in the routing table, there should need to be a separate column need to be there. So that actually you can, if it is a class-based addressing destination address it has found in the packet, the router will be able to use this next part to get the correct destination. So that is actually showing here with the examples. So if the routing table has been given, you'll be able to draw this figure. If the has been given, then you should have to complete this routing table. So this routing table we are having some examples. So every time that the higher to lower mask is going to be used, whenever you are finding like the correct network from the destination address of the packet. So we have seen them with both at least two examples we have done in the class and show you how actually it works. This is the part really I wanted to actually introduce with you net and that, but for the time we could not, so it is out of syllabus. Then we have to move to the unicast routing protocol. So you should need to know the intra-domain and inter-domain routing. So you should need to understand the inter-domain routing we are using, that is for making that connections of autonomous system. So there should need to be, actually there is a single routing protocol I can use, that is the BGP. But intra-domain routing is going to be used inside a autonomous system. So according to the packet network autonomous system size or space, I mean, more than one routing protocol, one or more than one routing protocol can be used inside a autonomous system, inter-routing protocol. So this is actually shown that inter-domain can be distance vector in step. One example we have shown for both of them, and that the path vector. This is actually the inter-domain PGP routing protocol we are actually using. Then we have moved for the graph instructions. We understand that the nodes and the links, routers and the links, weight of that the links. We understand them, and after that we are using discuss that the two algorithms, the Bellman-Ford algorithm from the distance vector and Dijkstra algorithm from the link state. So we have discussed the Bellman-Ford equation, and by applying this equation, we have found that what is the shortest path from U to Z. Then we have also tried to solve this part. We have actually, in detail, we have shown it to you that how the routing tables are going to be updated for the different nodes by applying the Bellman-Ford equation. Then the Dijkstra algorithm. So we have the example figure we have pointed out. So in that case, what happens that there is a source will be given, and from the source, all other nodes available in the network layout. So all the nodes are destinations. So we should need to find out that actually to the sender, if I want to go any node, what is going to be the least cost path, and that is done with the Dijkstra algorithm. So we have studied this algorithm. I think that we know already that how to find out the shortest path for all of the nodes. So this is with another example we have seen that, because we wanted to show that if there is a tie with the least cost path, then which one are going to be used. Because of that, actually, we have also discussed this example. And after that, we have moved to the data link layer, which is number 8. The data link layer we studied. We have just given some of the basic ideas. And then after that, we move to that actually the error control and error detection and correction. So we given a basic concept of it, and then we have moved to that discussions with the types of errors. We have understood the single bit, multi-bit, and burst errors. And after that, we have discussed some of the detection, error detection procedures like parity check, so cyclic redundancy check, and the checksum. So the parity check has been discussed. And after that, we have also discussed about the Hamming code. That with the Hamming code, how we are going to detect the error and how we are going to correct the error. Of course, it is the single bit error can be corrected by the Hamming code. Hamming code, so that is in detail, it has been discussed. There are some exercises have been given to you. So to do them at your home. And this is that actually that how we are going to detect the error and how we are going to correct the error. That is, yeah, for to say something. Yeah. Yeah, your voice is not clear. Please repeat. Yeah. Yeah, it has been said it into that portion. No, you will be given that the data, right? So if you are given that the data, then that the data you need to be encoded by applying the Hamming code procedure. You should need to be find it out. So we have explained it in here. You can see that. So this is what she said: generate 74 Hamming code for the data 1001. So from this data, actually, you have generate that 7 bits Hamming code. So 4 bits your data, then you understand that 3 bits is my parity bits, right? And also with that the formula we have shown that how you can find it out. So that the formula has been given to the power p greater than equal to p plus d plus 1. So if you're taking, for example, 2 to the power p equals 2, right? Then it's going to be 2 greater than equal p's value is 2 plus d has been given 4. So you are given that the 4 bits, so 4 and plus 1. So if you're taking it, then how much you're getting? 2 to the power 2 equals 4 greater than equal to 7.
7.
Is it true?
No, sir,
No,
it's
sir.
false.
That's why we have gone for 3. So with that the 3 we have find that 8 equal to 8. So is it true now for this formula?
Yes, sir.
Yes. So that we have found that the parity bit is going to be 3. So 4 bits is my data and 3 bits is my parity. So that is how it's 7. Understand or not? What? So that was your question, right? Again? Yeah, so you should need to be find it out that I mean based on that if it is given for example 8, total 8 bits, right? Okay, so for the 8 bits we have gone for 7. So you know that 2 to the power 0 that is going to be the parity bit 1 position. This is going to be the 2 to the power 1, that means second position is going to be P2, and 2 to the power 2 means 4. So fourth position is P4. So 5, 6, 7. So 2 to the power 3, right? This is going to be my 8th position. So my P8 is going to be this. So how many parities you are having? P1, P2, P3, P4. So on that case, what is going to be happen? You are going to be include another column here, right? That is going to be your P8. Understand? So that time you are going to be represent with that the 4 zeros. Okay? Understand or not? 0, 0, 0, 0. So with the 4 bits you should need to be continue. Up to how much? That total number of bits that is going to be generated. So here it was in total 7, right? In this example. So we say that if it is 8 and 5, for example, then it's coming 13. So you'll go up to that the serial 13 with that the 4 bits binary representation. Is it clear or not?
No, sir. Can you repeat it, sir?
Yeah. So it said that if it is said to you that 8 5, sorry, not 8 5, it should be said that it is 9 5, for example. So if it is 9 5, that means total number of data, total number of bits are 9. Okay, and out of that 5 bits your data, so that this is your data 10010. So 5 bits your data, right? So that means how many parity bits you required? 4, isn't it or not? Do you understand this? If it is given
Yes,
to
sir.
you that,
Now I get it.
right, if it is given that 9 comma 5, so 5 bits your data, so 9 minus 4, that means you need the 4 parity bits. Or if you're applying here, then you should need to be go with that the 4, right? Because you are having 2 to the power 4 means going to be it is 16. So 16 greater than equal to P means here that 4 and D has given 5. So 5 plus 1. So it is getting that 16 2 to the power 4 means 16 equal to it's getting 10 greater than equal to 10. So is it true or false?
False.
False. So that means you have to start with the 2 to the power 2 to the power 5. Okay, 2 to the power 4. Yeah, 2 to the power 4 and 5. Yes. So 2 to the power 5 you have to go for. If you're going for 2 to the power 5 greater than equal to you are having that the P's value is 5. So 5 plus 5 plus 1. So how much you get? 11. Yes or no?
Yes.
Yes, sir.
Right. So it is going to be also. So is it
4.
greater than equal? It is 2, right? 2 to the power 5 means what? 35. It is 2. Right. It is 2. So that means you are going to be take that the 2 to the power 4, right? P is equal to 4. Yes or no? Yeah. Why you have gone through this? It was the condition was successful because 16 we got the 16 greater than or equal to 10. So 16 is greater than 10. It's true, right? So that means we can understand that parity bits is going to be 4. So if it is the parity bit 4, so you are getting that how many bytes data you said? 5, isn't it or not?
Yes, sir.
So
5.
so this is your first data, second data, third data, fourth data, and 2 to the power 3 is your 8. So that's why you have given the P8. And then it is going to be that your D9. Do you understand that or not?
Yes, sir.
So that means total how many actually number of bits you are having? 9. Look that 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear or not?
Yes, sir. Clear.
So that means you totally going to go up to the 8 and 9. Clear? Clear?
স্যার এখানে কি 16 বিট বাইনারি রিপ্রেজেন্টেশনটা
Yeah,
ইউজ করব
16 bit, four 16 bits binary representation is going to be there. So with the 4 bits you have to do it. Now it is P1, P2, P4 and P8. Clear or not?
ইয়েস স্যার
Yeah. Yeah, so you are going to be doing that the 4 zeros, right? Look that it is what you have done 0 0 0 1 1 0 1 1, right? When he does, then what do you do? It's all zeros, 4 zeros, right? 4 zeros, zeros, isn't it or not? Now you are going for what? 1 0 0, right? Understand or not? 0 1 1 0 1 1. So it is going to be all 1, isn't it or not? So it is going to be here 0, all zeros. And then what is going to be happen? Then again you are going to be start with that 0 0, right?
ইয়েস
Get it
স্যার
or not? So
ইয়েস
this is
স্যার
where
দ্যাট
it is
অল
going to
ওয়ান
go on. Clear?
ইয়েস স্যার ক্লিয়ার
Yeah. So do it. I mean, yeah. So just, I mean, do it, and if you anything find it out, then you can do it, discuss it into the consultation hour. All right.
স্যার এখন কি গো এন্ড ব্যাকটা একটু 5 মিনিটস বুঝাই দেওয়া যাবে
No, no, no. Let me brief why I am taking the questions. Let me first review this what we have done. Okay. Okay. So
ওকে স্যার
please let us check that what you have done. So what the Hamming code we have done, and after that we have done that the cyclic redundancy check. So we have learned it out that from the CRC generator how can we can generate the bits, and then we have seen that how we are going
স্যার
to
স্যার আমরা যখন এক্সামে লিখবো তখন কি এগুলো দেখাই দেওয়া লাগবে যে সাইড নোটগুলো যে দেওয়া আছে না দিলে
no,
হবে না
this side note is not required. Yeah. So I mean that the CRC has been added with that the given data. The given data was like 100 100. So 100 100, that the CRC is added, and then the receiver side you have found this is yours including the CRC you have taken, and you are using the same divisor, and you're finding that 00 all 3 bits. If you're getting 0, that means there is no error. But if you're getting here the combination with 0 and 1, that means there is going to be the error. Okay. And the checksum that actually we have already discussed in the UDP, and we have learned it out here also we have discussed. So that I mean you just need to be apply that the formula, nothing else than that. And then we have moved to the lecture number sorry, after finishing that error detection and correction, then we have go back to that first part of this lecture number 8, and then we have talked about that the framing the general formatting data for transmission in the data link layer. So you know that when it will come from that the network layer to that the data link layer, we are going to be add with the data the header and tailor. So what is the inside of the header and tailor? That is the general format. That has been different fields we are having. So we have discussed them into these slides, all that the fields. And after that, we have talked about the types of frame, that fixed types, framing, variable size framing. Then we have talked about the different methods. So we have discussed them, the character count method, byte stuffing method, and bit stuffing method. And then we have discussed the flow control mechanism. Basically, there are five algorithms we have studied for noiseless channels, simplest and stop and wait. And for noisy channels, we have used that the flow control algorithm like stop and wait, ERQ, go back and ERQ, and selective repeat ERQ. So we have discussed them in detail, all of these protocols. So you should need to be practice them properly. And after that, we have gone through some questions. So the comparisons between these three, that you should need to be study, you should need to be understand properly that what are the procedure methods that these three protocols use, and what are the main differences between them, and actually who is better, and for which purposes they are better, that you should need to understand. Then there are some example questions that we have solved, discussed in the class. So up to this that we have done. So this is that from the lecture number 8 we have done, and the lecture number 9 yesterday we have done. So from that you should need to be understand that what is the digital and analog data, and digital and analog signal. Then what is that impairments, what are the types of the causes that for the impairment happens, that you should need to be just know about them. Okay, so these are the things that we have studied. So here, from here, that you should need to be know that data transmission, that parallel data transmission, serial data transmission. These are the two examples we have defined them, and we have compared them. Then for the serial, we have studied that asynchronous and synchronous, that you should need to be study the examples. And in the line, there are actually different type of conversion, but we have only studied the digital to digital conversion, and there some schemes are there. So only we have studied the line coding. So in that the line coding that you should need to be, because it is line coding is actually always needed, but block coding and the scrambling may or may not be needed. So the line coding that you should need to be study here, that what is that the line coding means, and then the different methods you're having here, that we have only learned that okay, by applying that the methods of that the each of that the unipolar, polar, and that the bipolar, that how actually we can draw that the waveforms. Okay, so that you should need to be practice that for unipolar, that how you are going to be draw that the waveforms, that coding techniques, unipolar encoding techniques. And for the polar, that the different methods that like NRL, NRZI. So these are the all of them actually you need to be practice according to the rules of those encoding schemes. You should need to be study Manchester, differentiate Manchester, and the bipolar. Okay, so all of them actually you should need to be practice that how to draw that the waveform by following some data. Okay, clear? Yeah, so these are the things actually we have studied into that the CSE 465 syllabus. So this is going to be your syllabus, and so keep studying, and if you have any problems, bring the problems into the consultation hour tomorrow at 8 p.m. Do you have any comments or anything?
Sir,
Yeah,
sir, I missed my attendance.
no attendance, it's not possible. Okay, so is there anything else that that you have any questions, any inquiries? No, right? All right, then thank you very much. This was the last class for the CSE 465. So make sure that you're studying and having a good preparation and give a good exam. Hopefully tomorrow we are going to be meet for the consultation at 8 p.m. Thank you very much. Take care, all of you.
Thank you, sir. Pray for us.
Assalamualaikum.
Assalamualaikum.